Intro theme song. Wait, mic check. Mic check. All right.
We're all connected to each other biologically, to the earth chemically, to the rest of the universe atomically.
I think nature's imagination is so much greater than man's. He's never gonna let us relax.
We live in an in-between universe where things change alright, but according to patterns, rules, or as we call them, laws of nature.
I'm this guy standing on a planet. Really, I'm just a speck. I'm just a speck compared with a star. The planet is just another speck. To think about all of this, to think about the vast emptiness of space. There's billions and billions of stars, billions and billions of specks.
The beauty of a living thing is not the atoms that go into it, but the way those atoms are put together. The cosmos is also within us. We're made of star stuff. We are a way of the cosmos to know itself. Across the sea of space, the stars are other sun. We've traveled this way before, and there is much to be learned.
We're all connected to each other biologically, to the earth chemically, to the rest of the universe atomically.
I find it elevating and exhilarating to discover that we live in a universe which permits the evolution of molecular machines as intricate and subtle as we.
I know that the molecules in my body are traceable to phenomena in the cosmos. That makes me want to grab people in the street and say, have you heard this?
The beauty of a living thing is not the atoms that go into it, but the way those atoms are put together. The cosmos is also within us. We're made of star stuff. We are a way of the cosmos to know itself.
There's this tremendous mass of waves all over in space, which is the light bouncing around the room, going from one thing to the other, and it's all really there, really there. But you gotta stop and think about it, about the complexity to really get the pleasure. It's all really there, really there. The inconceivable nature of nature. To think about all of this, to think about the vast emptiness of space. There's billions and billions of stars, billions and billions of specks.
The beauty of a living thing is not the atoms that go into it, but the way those atoms are put together. The cosmos is also within us. We're made of star stuff. We are a way of the cosmos to know itself. Across the sea of space, the stars are other sun. We've traveled this way before, and there is much to be learned.
All right. Sunkworks episode 32 is a vibe, as you can see. All right, let's begin here. So we said we're going to walk the premises this episode. these are not the premises here. These are some things from my friends I want to share with everyone. Here's another thing from some friends. We're not going to look at this in detail, but Cube Simplify is also a vibe. Flux subsystem for Argo, Flamingo had a release. Not in this location. Here, 1 hour ago. Today. It was 2 hours ago. Sorry, that's the wrong one. One hour ago. Yeah. Now, I'm going to preface this Timony stuff with I don't fully understand it yet. Or how it works. I know generally what it is. I know that when I was browsing through the docs, I found a reference to a Timony controller that does not exist yet. I wonder how this can be used. So the issue with the controller is without the controller you can't have imperative-like behavior like you have with the Helm release. Because you're just templating. You're bringing so there's hooks that run in a separate imperative process where these things happen in order, and if this thing doesn't happen, then that thing won't happen, and it's like a complicated logical process. And there are other features also that can't be achieved through the direct templating without additional hands-on, but I think this stuff is really cool, and I think it's going somewhere, so I'd keep my eye on that. Also, I'm a part of the Flux subsystem for Argo organization. I don't know if it's technically still part of Weaveworks, it says here. That's cool. I think this is the best entry point if you want to find out about Flux subsystem. Here we go. There's a website. Oh. What's going on here? That's interesting. Yeah, so Flamingo is for two types of user who are potentially the same user. If you're using Flux and you want to be able to see the statuses of your Flux configurations in a UI, I know there are other projects that you can use to do this. There's historically been Weave GitOps UI that is also comparable, but Flamingo is a project called also called Flux Subsystem for Argo to embed Flux runtime in Argo. So sort of cursed, twisted logic led us to implement this process where you can use an existing UI because we knew that at a point we didn't have a UI of our own other than the command line, and we knew that wasn't acceptable. It couldn't go on that way like in the future. So every time we tried to build a UI we would get humbled, basically, by how compare ourselves to every other UI and say, well, it doesn't do, like, there's a whole laundry list of things that you want your software to do, and where do you even start if it's a new project? It has to, eventually. Anyway, so what if we could just use an existing UI that's very good, that only deficiency is that it didn't really have visibility into the Flux resources. So I'm not entirely sure why this wasn't picked up upstream, and why they didn't choose to do it themselves. Maybe there's some bad juju. I don't know, like why anyone would want this or not want this. Hard to say until you've tried it. So we're going to try it. We're going to see if we can upgrade to the latest release that came out today, if we haven't already upgraded. I'm not sure if we've got automation in place, or if that's... I don't have the notifications really set up right, so I don't see everything that happens on my cluster. Partially owing to the fact that it's a multi-control plane cluster, so there's multiple instances of everything running on the cluster multiple times. And we're going to do just a little walk, and we're going to talk about some pathological cases, like what is the degenerative state that you don't want your cluster to be in. Things that we would risk if we have a scheme like a virtual cluster control plane mishmash, where we just create new clusters on the cluster when we want another cluster. What would happen if we said, oh, well, each cluster has an overhead of but also Prometheus monitoring is installed in every cluster. In this scheme, this would be disastrous, right? We really want Prometheus to run on the top level cluster, ideally. I think. I'm not sure what the right answer is, but I know the right answer is probably not for our scale, since I have 3 physical nodes, which could get overwhelmed easily if there were a lot of processes running on them. I suspect it's not going to be to run, well, we'll see, because we have a lot of memory. So, but I was going to not to run an instance of Prometheus per cluster. That seems like a risk that we would accidentally fall into that configuration and just wind up having 7 or 8 clusters on our 3-node cluster. By the time we're done, we're running 12 instances of Prometheus. That would, there's a risk that we might, so we have to be careful with the way that we implement templating. And that's the thing that I have not really done. I feel like I have a trail of bodies in my wake, like effect, where I've just gone and given lots of good advice, drive by new talk every week, have to show something else, and that there's a failure to go back and stitch the entire thing into a coherent demo that shows everything all at once. That's a travesty. We're going to have to resolve eventually, but today we're just walking the premises. So we're going to see how much we can see. We're going to see some limitations of the system here. See if we can log into that Argo like I promised. So this is the management repo for the top level cluster. Beneath that we have another Bootstrap repo and a later Fleet Infra repo. This is what I'm saying. But this is not a planned infrastructure. This is an infrastructure that evolved through all sorts of just learning experience. So we find lots of good examples as well as maybe poor examples where not everything is aligned in the same way across. Anyway, I'm looking for the Argo CD directory. I know that we have, maybe it's called Flamingo in here. So Home Workers is the name of the top level cluster. And then Talos Dev is our new cluster that does not have very much on it so far. It has cluster networking, it has Flux, it's bootstrapped, it's good to go, but it's not, also not, I need to crank up some lights here. Let's see if I can get a big white window on this screen. There. I don't have a ring light, but I have 2 monitors here, so. I watched a lot of lighting tutorials to have this poor lighting. I'm sorry. Okay, that looks a little bit better, I think. Don't have so much of the green screen fading in. I think it really depends on the outdoor light still, even with all the windows covered. Very interesting. Okay, so in this directory, we bootstrap our management cluster, and that is where Argo CD comes from. And this is the first example of I'm not doing the best everywhere. So this is the oldest repo with the least attention paid to maximizing good advice about repository structure. I'm saying don't do what I did here, whatever you do. Don't dump a bunch of stuff like this into the Flux. Let me show you what I mean. Well, this might be okay also. Usually what I do is I put things in apps. And in this instance, you can see I didn't put things in apps. I sort of put a few different environments in apps. And that might be reflected in here or not, I'm not sure. But so we've got an ingress, Nginx folder with lots of stuff in it. What I'm saying is you don't really want a lot of actual Kubernetes resources in your bootstrap directory, because Flux system is the bootstrap directory customization, and you want that one to finish quickly, and you can't set spec.wait, I think, on that for a reason that's like a cyclic dependency issue. So every other Flux customization, you're probably setting spec.wait to true, which is going to health check all of the resources, but in this customization we get no health checks. So that's reason number one why not do this. Put all these resources in the Flux system customization directly. Okay. This is good. This is what I wanted here. We're kind of talking through some issues that I'm not sure we've ever really talked about in GitOps session context. Let's see here. So these are a bunch of ingress definitions. And also a Helm release here. Right? So there's nothing health checking this Helm release, that's what I'm saying. But it has a what do you call this? Pessimistic operator. So let's look up the ingress Nginx chart and find out what's happening there. What's the latest release? .10. Okay. So does this operator mean only minor and patch release, I think? And then if it was a, well, let's see. Helm ls. We want to switch to that cluster. Yeah, so this is walk the premises. This is what I mean. We're going from cluster to cluster. We're going to look at what have we deployed across all these clusters, and then we're going to figure out what of it do we need to bring with us to Talos Dev. That's why we're doing this today. Argo CD maybe we don't need. I don't know. There's other stuff on here I'm sure we don't need. Okay, so Flamingo demo. I have a feeling this is, yeah, okay, we've got a specific tag in here, so this is not automated. OCI repository. Alright, so we're looking for version 10.2. That's what we want. Introduction. Tutorials. GitHub. Here's what I'm looking at. Version 10.2. So we've got source code here. Packages. Manifests. Do we have... It looks like we're not publishing OCI artifacts. Perhaps this is somehow the way that I can help. I haven't talked with Chanwit in a long time about Flamingo. You see, I have not actually made any direct contributions to it here, so collaborators, I'm not even listed. So how does it get the manifest? Curl. Oh, from main. V2.8.4, 10.2. Are we talking about the same version, or is that the Argo CD version? So I think I'm getting to a question about how is Flamingo versioned? Because I see some different version numbers here. I see this says 2.10.2. I saw that the version we're actually on now is 0.10.2. I wonder if that means that Flamingo went backwards in versions. Or if it doesn't align with Argo CD version release numbers. Let's see. 2.10.2 as the default version. Promoted 10.2 to the default version. Just going to see if I have any version of this installed, because it does look like I have this here. Even if this is not a current release pattern. How do we do this? Yeah, we have to log in with our Dex instance. Great. We have, it's not a Helm release. Here we go. Flux subsystem for Argo. Argo CD namespace. Oh, we don't have an ingress. I guess that's on purpose. I don't know. We'll log into Tailscale. This is a great thing that I don't exactly know if it's 100% open source, but I think that it's open source, at least open source enough. You can see how it works. I don't know if I can compile it and run it myself, but let's see. Here we want to see this. Great. Certificate authority invalid. That's okay. Hey, there we go. We don't even need to log in to see everything. That's amazing. Yeah, so I guess it's good that we don't have an ingress. Do log in? Can we do that? I don't know. I don't really need to log in. I mean, it looks like I can see everything. Can see this thing. Looks like it's out of sync. What does that mean? Out of sync from monitoring. I don't know. Can we figure out what does that mean? Status out of sync. What is this namespace monitoring? I don't see what's out of sync here. It says status out of sync. Apply out of sync only. Events? No events. Oh, okay. We've got a secret here. Promtail.yaml. Loki stack promtail. Alright, I don't care about any of that. Need to move. So, yeah, we've got one yellow light here. That's cool. I don't see anything. Alright, we're gonna upgrade this later, I think. Actually, let's try it now. Let's see. Let's see, can we do Flamingo demo? Alright, so if we can't just use the latest tag here. Maybe, I think we'll publish our own tag on a fork. And then we can sign our own release. That way we're not verifying some arbitrary person on the internet. We just verify our own release of the manifests. I think I've been training for this. Did this yesterday for the Hephy folks. Let's see how we're gonna do that. We're going to do that later, because we said we're going to walk the premises here, and we've just gotten to Argo CD. There's a lot more to look at here. So we've got a pretty lean stack, I would say, at the top level here, because actually we don't put our production apps here in this production apps. We put them into vclusters. So they all go somewhere on another cluster. Mostly they go historically on this one that's called Mu cluster, which we'll see in a minute. That's where the Harbor image registry lives. So we've got a public production Harbor image registry instance where you can host images. Harbor is automatically kept up to date, I think, by the Helm controller using another automation like what I mentioned. So because this isn't distributed as a Helm chart or a Timony module. I guess Timony modules are like Helm charts. Because this isn't distributed as one, there isn't a consistent upgrade path, apparently. It looks like it's very much distributed as a roll your own distro kind of thing. So, like, it's running an additional DEX instance that's not the DEX that I already configured to use for my entire cluster off. it just runs another DEX, because why wouldn't you want another DEX? I guess. I don't know. I have to go in there and figure all that stuff out later. But we can see it. We can see it here, right? Argo CD. We can see right there's a DEX server. That's for logging in, I guess. And there's like a Redis. Like, this is almost full Hippo factory, right? There's lots of stuff here. I don't know, what does a server do? It's obviously, it serves your requests. That's the UI server. The repo server, I guess, is a separate component. Like, this is an older version here. I think this must be around this version. I don't know, because the versions aren't really aligned. I think it's actually even older than this. See, this says 2.8.5, and that's the oldest version here. I haven't really configured this. I have. I will come back to it. But let's see, what else do we have in terms of namespaces. So we have a CAPI system, and what CAPI system does is it allows us to provision virtual clusters with declarative resources, right? So you don't just vcluster new or whatever. You don't just vcluster create vcluster with your CLI. You don't ever do that. You do it instead through declarative resources that you can then manage via GitOps if you want. Now, it just so happens I only manage some of my clusters via GitOps because I know about this chicken and egg conundrum, where it's not really relevant here, but okay, so we've got our vclusters. We'll take a look at them. And then I'm going to do something sneaky here. These are all OSS vclusters, which have inexplicably, even though they're declarative, inexplicably have been upgraded to 0.19.0. Don't ask me how I did that. It's a magic trick. Had to go behind the curtain. Okay, and so there's a few clusters here. There's a Hephy staging cluster that I run at the top level, and Mu cluster, the one that I just mentioned. We have gotten rid of a lot of clusters at the top level. And then we have this Howard Mumbu cluster, that's the full grand name. You know, it's like Charles Xavier the Third, Howard Mumbu Space, and Howard Mumbu Stage, which are the production and the staging cluster for our environments. So because we want to be able to show standing up and tearing down the whole of CAPI and everything else that it requires, we actually do this inside of a vCluster. Right, so this top level CAPI I've provisioned manually. I say manually, but it's just like 2 steps. You run cluster CTL init or whatever with your provider name, and it creates things for you, and it installs Cert Manager, I think, also. But I don't want to do that, right? I just said we're not doing that, so we don't ever want to run an imperative command against the cluster. We want to run it via GitOps. So that's what we do inside of here. Out here in the real world, we just do once in a while run an imperative command against the cluster. But in the GitOps cluster, we have not done that. We have instead applied the CAPI resources via GitOps, and as a result, they're a little bit more out of date because someone has to figure out how to extract them from the release and then put them into our system, and we don't have a pipeline for that that's automated. That automated pipeline, I did this yesterday, but I have not recorded it at all. So we have a new release of Hephy Workflow here. I'll show you. Blog teamhephy.info. Here, if you go to the About page, we have this new version. It's published yesterday, and it's the test version. Let's see. So I want to get through. See if any of these namespaces are relevant. We're going to go into that Howard Mumbu space cluster. We're going to go into the Mu cluster. We'll go into the Hephy stage cluster. I'm going to be honest. I have not used the staging cluster for Howard Mumbu. It's just like dead weight that sits next to the production cluster where everything gets tried for the first time. Sorry, not sorry. And then we've got Tailscale that runs at the top level, and we've got pod info, because why not? We've got MetalLB, that's really important. Tailscale, MetalLB, we might want both of those, or we might just want MetalLB. Probably not going to take Tailscale with us, I think. It's been extremely valuable, but it's at least we will not take it in the form that we have it here, because when I implemented this, it was uphill both ways. They didn't have Tailscale operator that you could install and do your Tailscale configuration with CRDs. So I just had to cobble together my own manifest by hand. And you did it. You liked it because it was much easier than having to manage servers through Ansible or some other imperative process. Because with everything in GitOps, you get a reliable guarantee that you can just stand it back up again. If you have to destroy the entire thing, you can put the experiment back the way it was. That's great, right? So we want to never run commands imperatively against the cluster if we can avoid it. We want to always put things in Git and manage them in a GitOps way instead of just realize you probably can't read all this here. There, that's better. So shout out to the Loft who created vcluster. I have Loft installed on here as well, although I don't use it. It was one of the first things I installed in this cluster because I needed to be able to get access remotely, and I hadn't set up things like Dex, Auth, and Weave GitOps Enterprise yet. Shout out to Weave GitOps Enterprise that taught me to install and configure my own Dex, which I have taken with me beyond the useful life of Weave GitOps Enterprise so far. I say this not to disparage or take anything away from the great work that was done there, but I cannot recommend it in its current state because a lot of the doc sites are unfortunately down, and I know that there are people working on that, volunteers, I think, who are from outside of the original Weaveworks company and some inside. At least I know Alexis Richardson has been great trying to wrangle people together to, but again, it's in a state where I cannot currently recommend, unfortunately. But if you're interested in such things, if you want to volunteer for a thing like that, or participate in any way, as a business or sponsor, or feel free to reach out to him or me. I have no relationship with Alexis Richardson, no business relationship with Weaveworks at this present moment. So, God, we're into talking about ex-girlfriend now. This is like, feels, this is my show, right? I can talk about what I want. That's right. Okay. All right. KWASM stuff. I forget how that turned out exactly, but KWASM, you can run an entire WebAssembly as a container instead of. I mean, that's really cool. I wasn't able to use it effectively, but it was a neat thing to experiment with. What I wound up doing instead was running WebAssemblies in a traditional, some hosted environment. So there, I think this is actually a great time to pull out this link. So this project I saw, I think it's great, and I would like to try it again. I haven't really dove in properly, but when I went to read their docs, I found that they were organized exactly the way that I expected they should be, and that they had everything in. I don't know if anyone remembers my WebAssembly talks from Vancouver, from OSS Summit, but I was deeply confused about how, when I started to approach WebAssembly as a technology, as a technologist, to like say what is the buzz about WebAssembly, that was my entry point. I didn't have a specific purpose. I did have a goal in mind. I wanted to build a Kubernetes operator in WebAssembly, but I found that it was very difficult to use it that way. What this framework does is it sort of lets you plug in, and I guess this is what I did wind up finally doing. If you go back to look at the OSS Summit talk, we built a Kubernetes operator in Ruby, and then it managed a project and leaf nodes, sort of. So, forget about the relationship and what the software actually does. It's just, managing some hierarchy, right? That's what our Kubernetes operator always does, obviously. There's something at the top level that says, here's the project definition, and go fan out to find all of the leaf nodes, and then check in with each leaf node somehow. So it was counting packages on leaves of Kubernetes, GitHub repositories that connected to OCI packages. All right, so this is going to be a persistent theme, because this is how we think you should distribute your software for Kubernetes in the future. Excuse me, God, I have some kind of gas thing going on. I'm not used to talking this much anymore. I live kind of a lonely daytime life. I should probably stream more, even if I'm going on vacation next week, so you might not see me for a few weeks. And don't think that anything happened to me. The only thing that's happening is I'm having a good time with my wife of 8 years. We're going to the wilderness to enjoy the wilderness. Hopefully we'll get to do some skiing. Anyway, what our Kubernetes operator did with WebAssembly was it ran on each leaf the terminal function operation with a WebAssembly module, and that was what we presented at OSS Summit. And we might do something like that again, but we kind of had to figure out, roll our own, how do you run a WebAssembly inside of a Ruby program, and this is sort of like you should not be figuring that stuff out, right? If you're trying to build anything, you want to focus on whatever it is that your domain experience is focused on, which is, I mean, for some of you, I'm sure it's WebAssembly technology and stuff like that. But for me, if I'm using WebAssembly, it should be a side note. In it's not the focus of the project. Whatever it is that we're doing, like counting up project packages or something. I don't know. That's what we did, and we should be able to use WebAssembly if it helps us somehow, make some operation faster or something, so I sort of approached it with like someday WebAssembly will help me make some operation faster. In the meantime, I just want to be able to use it productively for any purpose, whether it makes it faster or slower. It doesn't matter. I just want to be able to exercise the technology until I understand it well enough that opportunity, when it comes along, I'll be able to grab it rather than have to do 6 months of research because I still don't have any idea what WebAssembly even is or how to use it at all. Uh, so that's what this software does. You pick your language that you work in, and you just say, I want to use this XTism library, and you grab your WebAssembly module. Maybe it's manifest. I think the manifest thing is somehow related to how does the WebAssembly run, and it's somehow embedded in the WebAssembly bundle. And then you declare a plugin, and that plugin, and this is the thing that I couldn't figure out how to do, is to be able to call functions on your WebAssembly. Right, we've just got a function called count vowels that the WebAssembly exposes. That's what the manifest does. It says what functions it exposes, or memory, or there's a short list of things that you can do in a WebAssembly if you understand the interface, and then it gets longer or shorter depending on what interfaces you put on top, like WASI or and I don't keep up with the details of that stuff, so my understanding of that stuff is all at least like 12 months old, I think. But that's at a fundamental level. That's what they're building now. There's the component model that's new, and other things. But this plugin, this plugin framework is, I think, like a stable way to view WebAssembly that you can just pick up and use. So we'll do that again sometime. That's great. Yep. All right. So this blog is hosted on one of these clusters here. We'll see which cluster. kubectx Hephy. So what I want you to notice is that we have these 5 clusters, counting here, the top level cluster management, and also these clusters. But if I run kubectx, I have more than 5 clusters here because we have clusters that run inside of this Howard space, and we have the Talos cluster that runs outside of management. We have also this cluster, they run inside Howard space. But we're going to look at Hephy stage right now, which runs outside of Howard space. It runs inside of the management cluster. It's a sister of Howard space and Howard stage, let's say. So, so this is Deus Workflow, or Hephy Workflow, actually. And you can see it's stripped down. If you know Deus Workflow, there's a couple of things that usually you would see more, like a database. There's a few other things that were run externally. The Minio here is not your traditional Minio. It's been patched. Get PVC. So if you're familiar with Deus Workflow, the first thing you usually do is configure storage to work with a remote external storage so that your cluster is stateless. But what instead we've done here is made our cluster stateful by making the PVC attached to Minio. So Minio actually has local path storage. So when Minio goes down and comes back up, the data that was written into Minio is actually not lost. If you follow the instructions here and you go to install Hephy Workflow from these charts, then you will not get this configuration, I think. So let's go back here and see where is this configuration coming from. Not this repo. It's in a different repo, right? Clusters. No, yeah. Yeah, so here we have the Hephy staging cluster. Right, this is a much better organization for your cluster. We have only Flux resources here and namespaces in our Flux system tree. And I have to move this over again. That's behind me, sorry. So when I say, if you're not familiar with the structure of a Flux bootstrap, this Flux system directory here is not the entire Flux system customization, right? The entire Flux system customization is all of this. So I didn't add anything in the Flux system directory because it has a customization.yaml which lists the specific files to run. And there's one in here. This is something I put in. I think I should system customization. Probably removed that already. Yeah, it's been removed. But you can add your own patches in this customization.yaml, which indeed we've done in the past, and sometimes we overwrite our controllers, our Flux controller arguments or something. So these configurations come from the Flux website here. Flux. If you go to documentation, installation, configuration, you'll see those configuration come with, I think, this bootstrap customization. Describes those things that I did there. Some of them. Yeah, so here we've added concurrent 5, right? This is just an option that you can tune. If you want more or less concurrency than the default amount of concurrency, that's where you tune it in customization.yaml. Things that are system-wide go in here, which typically you don't want to have that many system-wide configuration because you shouldn't have to reason about the state that the system is configured in. All right, but we've set this rate limit interval to 10 seconds so that we don't, there's rate limiting in the notification controller when you make an event. If you have something that happens multiple times, the same event wouldn't get broadcast more than once because it gets rate limited. But we have set this rate limit very low so that we will see if something is spamming notification. We'll see it right away instead of having to wait for the rate limit. We would be able to see at least after 10 seconds, we'd be able to see it again. And requeue dependency. So there's a dependency queue where it waits like 30 seconds if something is not ready for its neighbor and you've got things organized in a dependency order. And I find for demos 30-second wait is a little bit too long, and maybe even for my production workloads I think it would be nice if they progressed a little bit more quickly than that. But your mileage may vary, so I have this set to 3, and we have concurrent set to 6 here. And we have set a limit, CPU memory limits here, which I don't know if that's in here as good advice. I think here the limit is actually to increase the limit here. Yeah, so we've followed the same advice here that the vertical scaling notes prescribe, except we haven't set a CPU limit, I guess. But we've basically followed this advice here, the vertical scaling advice for Flux. And there's also horizontal scaling that you can achieve through sharding, but most people won't need this. This is for very, very large configurations. Multi-tenancy lockdown. I guess, yeah, so the idea is that instead of scaling out your clusters to such grand proportion, you well, maybe the reason that you need to is because you have built it for multi-tenancy. So you want to be able to have one Flux controller that manages multiple tenants on a single cluster, and they should be able to do this without gaining access to each other's privileged sections of the cluster, right? They should be isolated as tenants. which I'm not sure is fully compatible with the idea of using workload identity, right? Because you need to guarantee that someone doesn't land on a particular node. So, I mean, there are systems for doing that, but you might have separate clusters for separate workloads instead, and then that would be the way that you achieve horizontal scaling, is instead of having one massive cluster that needs one flux controller managing everything, which it can do. You can crank up the concurrency fairly high, I think, and they've done testing to make it benchmark to see. There are published benchmarks actually for more recent releases of Flux. Anyway, we're getting into Flux now, which is cool and all, but a bit outside of the parameters of what we said we were going to do today, which is walking the premises. So we've got our Hephy Workflow. We've got all the things that are running on it. So here's the blog. That's why I came here. I wanted to show you that blog that we were looking at earlier is running here on this cluster. And we've got a couple of ingresses. We've got an ingress for docs. We've got an ingress for how-to. We've got an ingress, an internal ingress that we can use to access Deus Workflow, the API, if we're on the internal network here, the Tailscale network, or my home network. You can just turn off Tailscale and I'm still on the internal network. And these IP addresses are provided by MetalLB. Now, how do we do that? It's a cool trick. With vCluster, you can opt into the service network. I guess you are automatically opted into the service network of the host, right? Your whole network is defined by the host. So it's an interesting kind of multi-tenancy where we're not rigorously guaranteed separation from the others. And in fact, we can point to specific places where we can crosstalk and the potential for crosstalk exists. And it would need to be guarded against if you really thought that your tenants were adversarial to one another. So we can come back to that stuff. So these websites all work anyway. We've got Deus Workflow docs here, and we've got how do you log into this cluster docs here. This is the actual way. So I told you that I'm using Talos, but the first thing I had to configure for myself, I wanted to be able to see that Talos could accept OIDC tokens, that I could configure the API server to accept them at the top level. So I can use OIDC to access, my next cluster, because I've got all these clusters here, and I don't want to have to log into them all separately. That would be a terrible experience. I might have to go pay a cloud provider to solve it for me. But thanks Talos, because I didn't have to. KubeADM is also able to be configured this way. I'm going to go to the KubeADM configuration because I want to see. I know the Talos config file contains secrets, and I just want to call out that this old KubeADM config did not contain any secrets, for me at least. Maybe there were configurations where it would contain secrets, but the Talos config does unfortunately contain some secrets, which I guess is unavoidable at a top level. But I would like to put that behind a lock and key and just never access that again if I could. Use things like automation like Curie to make sure that nodes get rebooted on schedule. But I guess that's not really how your Talos admin experience goes. I need to pause, take a break. The Hephy cluster, we've seen the management cluster, we've seen all the various services that run on the management cluster, I think. We saw MetalLB, I hope. We are going to see that one again later. We saw kubeadm config from the old cluster. Now these nodes are different than Talos nodes because you can SSH into these nodes and they have a root context like this. What I found is the Talos nodes don't so much as such. Like if you know about Cureed, here we'll see Cureed. Take a look at Cureed. I have a bash alias, Cureed, that runs a function. I think it's called check on Cureed, which is telling me right now none of the nodes need to be rebooted. Now we're going to reboot some nodes here, because this is part of walking the premises, I suppose. So HP1 does not listen to SSH anymore. This is our new Talos node. MSI is the other node. So these two nodes both need to be rebooted. And we're gonna do some upgrades first. Update here. Dist upgrade. That's what I want. Kubernetes Xenial no longer has... Alright, what is it called now? How do you... Debian rules. There we go. I think I have all that stuff already. That looks trustworthy. I think this is source.list.d. Not Docker. No, I want Kubernetes.list. There. Now it's this one. Stable 129 deb. Oh. So we have a particular version of Kubernetes here. Hopefully it's still supported. 29 here. We want 23. Right? This is not correct syntax. I don't know how I got here. Wait a minute. Is that right? That looks right. .403 forbidden. Okay, I guess we can't get the version that we want anymore. That's kind of disappointing. I guess it's not supported. That's very... I'm very surprised that they don't serve old releases so you can install them anymore. Apparently. Alright, well anyway. Not going to get hung up on it. Here we have to do the same thing here. guess you were just meant to run this here. Then you can look at this file and see it gets the content there. That's great. Apt, oops, upgrade. Yeah, so this is, are we not actually, damn. I'm sorry, folks. I thought you were still watching along with me here. It looks like we froze. The screen froze anyway. Or we're looking at the wrong... We back? We're back. Yeah, alright. So this is... I'm so sorry. I thought you all were following along with me. I wasn't looking at the preview. It looks like the last few minutes we haven't seen a thing that's happened on my screen. But now you can see I'm doing apt-get upgrades and on both nodes of the old Kubernetes cluster. And this is the sort of thing that we don't want to see on our new cluster anymore. We don't have to see this. We just destructively replace nodes when it's time to upgrade them. Or at least destructively replace, cycle out the read-only file system for a new one using the AB swap method I think I saw first pioneered by CoreOS. I think it's called Project Omaha originally, but I'm sure that's not exactly what's used in Talos. I think Talos has their own special blend, their own brew. Alright, so anyway, we're going to do all these apt-get upgrades because we've got these two lovely machines we can SSH into still. And there's actually a third one that runs Fedora that isn't a Kubernetes node anymore. So that was the one that had a host named Moo. Then we took that out of the cluster, and the Moo cluster lived on in virtual form, even without the Moo node. There was no Moo node anymore. Now there's no HP1 node, and maybe in the future we'll take away another node or both nodes, and the Howard Mumbu Space project can go fully virtual. That would be neat, I think. I see these errors say, but removing anyway as you requested. I didn't request that, but I'm going to assume that whoever requested it on my behalf knew what they were doing. Looks like this one's still downloading. So we're talking about QRead, which is how I got here to we're going to upgrade the nodes. When we do the upgrade, sometimes something like a new kernel will come along and it will deposit a file that says reboot required. That file on the host machine lives in the host file system, which you would not expect to be able to access from inside of a Kubernetes container if you did not know how to break out of such things. You might assume that is impossible, or so maybe it should be impossible. Maybe I haven't seen for certain that it is impossible on Talos, but I get the sense that it's very difficult comparatively to get a shell on a Talos node, like a root shell at the host permissions, like I don't know, ns-enter, right? There's no ns-enter binary on the host system, so that automatically becomes more difficult. I'm saying ns-enter because ns-enter is one of the tricks that is used in the permission context by QRead to get access to the host. So what we'll see when this upgrade is done, perhaps, or if we have to create the file manually, we'll see is that the nodes get cycled through in an orderly fashion and they organize with each other, and QRead does the reboot. Curie runs reboot when it's taken each node out using drain and cordon approach. So everything that was running on that node before it gets shut down permanently, we're going to try and see if we can migrate it somewhere else. And if there's anything that can't migrate somewhere else, we're just going to shut it down anyway, and it's okay because this node is just going to come right back. But these nodes actually do have persistent data on them, on their local file system that we care about. Each node, that's the only place that I've used. I haven't set up anything like a distributed file system store. So one of my good friends is working on something like that. We're going to do another little... Where did we find that here? They put themselves on the Flux adopters page. We're going to look at that. Here we go. This is the one. Enix came up with this thing called Cozy Stack that I'd like to check out. This is actually an open source PaaS platform that runs on Talos Linux. And it supposedly does a lot of the things that I'm going to recommend we do. But we're going to do them individually. We're going to manage them all with GitOps ourselves. And maybe I'll come around to this. So answers questions neatly like, well, if we want another cluster, how do we get the virtual machines for that cluster? We've got a virtual machine instance in here. Okay, well, what if we need like a database or something? We've got all that too. How about load balancers? Yes, or TCP load balancers. Why is it always TCP? Why do they never have UDP solutions here? That's what we need. Anyway. Anyway, these machines have a lot to upgrade because it haven't been upgraded in a little while because I've had some other things to focus on. And we're just taking this diversion to talk about Curie because we want to see what are the advantages. We're going to try to install Curie. We'll probably see that it doesn't work on our new Talos cluster. Can you call these advantages? Are they really advantages? I'm not sure, right? I think yeah, sure, they're definitely, but we saw an interesting thread in the Argo. I actually followed your, I think Dan Garfield put this Argo CD subtweet about going on vacation to announce that your company was bought. Not that you were on vacation. I'm saying, out of office we had all these things we needed to do. And coming back and finding a thread with 100 comments on it. Oh no, what happened while I was gone? So we are dropping some frames. So I think we're going to call it soon. But we do still have a little bit of perimeter to walk. We have to go through the inner clusters, so I want to show you that. We haven't seen Fleet Infra at all, although I think we've seen that one before. Let's see, so we saw some of Bootstrap repo. A lot of these clusters are defunct, and then there's this basis directory, which you should understand is a thing that's related to Weave GitOps. And actually, I want to remove these core DNS things. I think that we don't need them anymore. We used this core DNS patch to bring nodes back when they had the earlier version of vCluster that was incompatible with core DNS latest, I think. It's a long story, but we'll see. We'll see here on the Hephy staging cluster. Since we're inside of a virtual cluster, we have no idea that we're hosted on. Right, we actually see a node. It looks like we're running on a node, maybe just one node, not both nodes. But we don't see all of the vClusters from the parent cluster. Anyway, we're going to go up to that parent cluster and look at those again. we see Howard Moonboo here. We're going to switch to him as another cluster, and again we have no idea that we're running on a parent cluster. We see there's actually virtual clusters inside of this cluster. There's just, it happens to be just one right now. Here we go. But we can do cube CTX into there. And see, this one is forbidden because it hasn't been bootstrapped yet. So how do we connect in the case that it's forbidden? Here we can use so we've got our vcluster CLI. vcluster connect. Alright, it says we need another terminal, but I'm going to use some shell forward magic. Okay, let's see. So there's not much running on this cluster, and that's the point. We can come here and do our experiment in an empty context that doesn't have anything except for absolute required cluster services like core DNS. We need to be able to resolve services on the cluster. We need to be able to launch pods, so we need our Kubernetes API. kubedns, I'm not sure how that's different than core DNS. I guess those are the same thing. That's the service, and this is the deployment. And there's just one pod, right? So that's the only pod that's running on the cluster right now. We don't see the control plane because it's hosted externally. So this is really neat, right? And if we go back to Howard Space, we can see there's loads of stuff running on this cluster here that we don't see. And then we've got our test namespace with our Limno Central. There's that control plane, and there's that core DNS pod, that one core DNS pod. And don't mind that it's mixed up with all the other right there in a different namespace, but our cluster lives entirely in that namespace test. So that's really cool. And then that we can run a full CAPI. I mean, you maybe think it's kind of cool, but then realize we've done all of the experiments that led us to running this virtual cluster. We've repeated them again inside the virtual cluster, and they all still work. So we can have virtual clusters and virtual clusters as deep as we want. I've capped it at one sub-cluster. That's my limit because I can't see any use in going any deeper than that. And I'm afraid of, like, what if infinitely nested clusters manifest an AI apocalypse? I don't know. Anyway, so this is where DEX actually runs inside of Howard Moonboo. This is our DEX that we've configured. And that's what I'm most worried about when I want to take all this down. I think that's actually one of the only things that's left served on this cluster, because we've GitOps is gone. So we're left with like our GitHub app secret app, which it's useful for me. I said I'd commit to fork it, and I don't know about maintain it, but I'm going to use it at least, so I'm going to need to maintain it so I can do builds on newer versions of Go as they come out, I guess. Cluster API, we've got our one cluster. More cluster API stuff, cert manager. Really, there's nothing else here other than DEX. But if I take DEX down, I won't be able to access any of my clusters anymore. Speaking of which, we have to finish our upgrade here. What is the difference in configuration here? What is fwupd? I don't think I ever configured this. I think those all look like fine defaults, so yes, go ahead and do it. So these are the types of events that we're going to free ourselves from in the future by only using Talos, I think. We're not going to have a machine to SSH into where you have to run apt-get upgrade or be negligent, those things. And I know you can automate some of this, but right, you have to make sure that it works. You can't just automate the world away. But you can make things simpler. I guess the premise of Talos Linux is that it's just enough Linux to run Kubernetes. It doesn't have a heavyweight init system. It just has a simple, basic. All right, so var run. All right, so there's no reboot required file here, so we're going to create one. Touch reboot required, and we're going to go back to management here. Curried. Oh, it's in Cube System, actually, I guess. So we've got WeaveNet here. This is the new WeaveNet, by the way. This is the upgraded WeaveNet with Raj Chaudhry. Yes. There's a formal release here now. So if you want to use WeaveNet, now that Weave.works is gone, you can install it from here. And here's your kubectl apply command. This is your one-liner if you're looking for it from the docs. I'm probably going to get my first commit in Kubernetes website unless someone beats me to it by making this. I've already suggested in the thread, but it would be probably cool of me to make a PR so no one else has to go and do it. So these Curried pods, here we go. You want to see what node are they running on. Each one is running on a different node, right? This is a daemon set, and it looks like we've actually already started rebooting. Abort kernel removal. Yeah, so it's already cordoned one node here, HP Worker 02. That's the one that we put that reboot required in. And it's, you can put that reboot required in both nodes at the same time. It's only going to cordon one node at a time and reboot that one node. So it's careful like that. We see the core DNS pod is pending. We see metric server is pending. Terminating. Yeah, so we're just going to reboot both nodes. And when they come back, I think because we've upgraded our vclusters, when we come back, we've upgraded our vclusters to a reasonably current control plane chart. They will all come back healthy. With core DNS talking, and we won't have a bunch of alerts that we need to manually go around to each cluster. I think if you've seen this before, if you've seen this show, this is one of the persistent difficulties that we've never quite been able to resolve because we had yet to grow past that issue of the vCluster CAPI provider needing upgrade. But needing update upstream, I guess, because it's all right. Cool. Ping HP2. It is either about to reboot or it has already rebooted, but the control plane is down. This is a single node control plane. In the future with Talos, we'll probably add multiple masters because it is production concern, I guess. It would be one of the first things they tell you to do in the installation manual. I haven't done that because so far I only have one node. And that's just peachy. Alright, we lost our connection now. Here now we've undone our vCluster connect. Right. Okay. So we're waiting, I think at this point we're waiting for this node to go down, and then it will come back. Fingers crossed. And then we will see the other one reboot, which I'm not sure if we finished our upgrade yet. No? Looks like we've still got more upgrade to do. I'm not sure what happened there. All those errors did look kind of ominous. Oh, we're not watch. What the hell? My screen is frozen again. No, it's not. No, it's not. Part of it is. You can only see. I'm not sure I understand. That's very odd. I have over here, I have the preview. I'm looking at the preview, and it looks like something different than this actual screen that I'm looking at on full screen over here. But ever so slightly, not sure. Okay, let's see. You are running and attempting to remove the same version. This can make the system unbootable, as it will remove boot and all modules under. It is highly recommended to abort the kernel removal unless you are prepared to fix the system after I don't know if I am prepared to fix the system. I guess I have to be. I hear the machine rebooting now, by the way. Yeah, it is rebooting. I don't know if the mic was able to pick that up. I don't know. I've never seen it do that before. I don't know why it would need to remove the running kernel to upgrade to the next kernel. It doesn't do that on its own, does it? Alright, it's coming back online. Can we SSH in? MOTD. Well, I hope we don't break the entire cluster, but maybe we'll accelerate this whole migration to Talos thing if this goes south. I don't know. I still think that I need some physical nodes that I can SSH into, but I'm not sure. I'm honestly not sure. I don't know about this. No, I want to keep my configuration here. The default action is to keep your current version. That's good. Alright, so we rebooted that node successfully, right? We didn't have to run reboot at all. It did reboot. And we're going to do the same thing over here. Once we confirm that there is a kernel that can boot. I'm not sure, again, I'm not sure why it felt the need to remove the running kernel. Usually you install the new kernel alongside of the old kernel, then you update, or not you update, but there's a script that updates boot config file. Here we go. Yeah, go ahead. fwupd. I don't even know what fwupd is. That firewall upd? I don't know what that means. I'm going to look it up. upd. Allow session software firmware updater to update firmware. Alright, sure. I'm sure I've never touched that before. So I just want to be careful to avoid, because I know there was a like a chicken and the egg issue with Dex, that if Dex was down, then clusters wouldn't work, and I wouldn't be able to log in to the, and it doesn't look like, right, I can, oh, I did get must be authorized. That's interesting. Am I still getting must be authorized? Or can I get over there? Right, so what I'm saying is that Dex actually has to be up when the API server comes up, or I won't be able to log in because it doesn't have a Dex token. Dex is a stateful component. It has like its own crypto keys to manage. So if Dex is down, and let's see if we can fix the management cluster. Can we get anything from here? Because we've got a static token here, so we should be able to interface with the API server, even if it couldn't reach Dex in time, I think. But we'll see. I don't know. It might be down. We're not getting to... I don't want to lose track of my upgrade here. Linux image. Yeah, so our API is up. We can see Flux customizations, for example. See some of them are reconciling, seem to be in progress. How about pods? Probably we're in the middle of a storm of pods coming up, because we've really just taken a huge bite out of our... It's no longer a third of our cluster. It's now a full half of our cluster, at least. It might be more. So we've got crash loop back off. Pending, error, pending, crash loop back off. So this is where I have this command that is called what's wrong, for when I want to see if this number of things in this list is actually going down or not. I mean, by this list, I mean the list of what's wrong, which looks like almost everything at this point, but if we run this command a few times, we should be able to see if it's more or less than any other time, right? Just at a glance, we'd see there's about 2 pages of stuff wrong here. If we run it again, see, we see init 0 of 2, so that's promising, because that's a thing. That's a control plane that we do need to see come up before other things will work. got a few things in pending, error, container creating. Container creating is though, right, that's promising. It's a new container and it's in creating. But our control plane is a bit slow. Here we go. Is it still 2 pages? It looks like it might still be about 2 pages. We see some things are in it. MetalLB is controller is in crash loop back off. Now when let's see, 90 seconds ago. So I don't really see a lot of things. See, I don't have a good explanation for why it didn't come up this time, because I thought that my upgraded vclusters would all be fine. Out of pods. Well, that's one I've never seen. Out of pods. Look at that. Out of pods. Oh no. Out of pods. What did we learn today? See, the thing is, this node, we've also upgraded it to containerd, so I don't even know how to go in and delete all the Docker. Like, I can't just go do Docker rm, Docker, restart. I guess we could do kubelet restart, maybe. Sudo stop kubelet. Oops. Containerd. Just try again. Start everything over. Man, I don't know what I broke, but I'm afraid to reboot the next one. We're going to do it anyway, though. But what I think is going to happen is, since everything is down, this is not going to happen right away, because Curated is going to wait for the previous node to come back before it touches. So we'll ping MSI, and that one will stay up at least as long as it takes us to bring this other node back. Hopefully we can do it. Let's see. PS. Got Nginx's, containerd shims. Wow, there's lots of stuff on here. I thought I stopped all that stuff, didn't I? Containerd shims. No, I guess I didn't. Huh. Containerd restart all containers. So I think what's happening is this is a side effect of having fewer nodes, because I was previously able to restart the control plane node without taking decks down, and now I'm not able to do that. So I need to start thinking seriously about high availability. I don't think the place to do that is with the storage. I think we're going to continue to use local PVs for storage for quite some time. But I do think we're going to make a high availability control plane and a high availability DEX installation so that we can reboot a node at a time without having any catastrophe befall us. And I'm not sure if we're going to need to reconfigure a few things to bring the cluster back up now. Let's see. It looks like we might be actually coming back now. I'm not sure. We got container creatings. That looks better. Lots of pending still. At least what's wrong returns quickly now. That's good. We've got lots of container creatings and inits. All of our containers are pretty new. I wonder if Curied was able to do its job to bring back the node into the quorum to uncordon, I guess. Yeah, it still says not... Oh, the other one is not ready now. Oh, okay, so we are actually back. And the other node is, in fact, going to reboot. It already rebooted. Look at that. We missed it. That's great. That's awesome. Ready. And it's coming back. Cool. Cool, man. Cool. That's real cool. I gotta sit a little bit further over here so that we don't have this problem. That's better. I like that. I think that's fine. Good. How does it look if I go to like full screen? Oh, that's perfect. It's exactly where I want to sit. Great. Yeah, I have a microphone in front of me. This is much better. So, is the node coming back? It says it's ready, scheduling disabled. Yeah, I think it's just waiting for Curie to realize that it's okay. Let's see, do we have authorization again? Wait a minute. Management? No, we do not. Well, this list is definitely getting shorter. These are all the things that ran on the MSI gaming node.
Welcome to the WebAssembly.
I recommend you check out this WebAssembly course. I'm sure it's very good. Oh. I didn't realize I had my sound muted. Hopefully that didn't change anything you could hear. Alright, so it's back in the pool. So we should see the rest of these pods come back. And hopefully we might need to one more time restart the API server here so that it authorizes our DEX, our new DEX pod, which I think has different keys. I'm not exactly sure how that works. I mean, I am pretty sure I know how that works because it's this kubeadm config file here, and I've configured this myself, so I'm pretty sure I know how it works, but I mean, it's just YAML, so maybe I don't really know how it works. Yeah, this list is definitely getting shorter now. We know a lot of these errors are going to go away too. Go here. I'm just going to delete those. So I think we need to kick the API server. I don't think that's blocking any of these things, although we have these 4 unknown GitHub app secret. I don't know why they're unknown. Maybe we should delete those too. I think all of these are just going to come back on their own now, except for the helper pods. What is helper pod delete PVC? Local path storage. I'm not sure I've seen that before. So we've got the API server here. This is it, right? Yeah, Kube API server. We're going to look at the logs. And I bet what we're going to find up here near the top is failure to reach the DEX at init time. Way up here somewhere. Maybe I should have used the head command to look at the top of the file. Sorry, I didn't want to cough into the microphone. A pet peeve. Here's what I wanted to see. Yep, cannot connect to, okay, so we want to restart this pod. It should come right back. It did. And now, of course, we can get into the cluster. That's great. Using our OIDC token. Yeah, so this is all part of this walking the premises thing here, because we would like to not have to have these things happen, but also that means we have to adopt high availability, which in a way we've never fully embraced before. So I don't know which we am I talking about. This is just me here, but okay. Cool. So can we still get into our child clusters now? Hard space. Yeah, we can. All right, good. Looks like everything's fine now. What about Talos? We can get into Talos now too. Okay, good. That's good. All right. So how are we gonna? Well, I guess I have some planning to do. I have some more writing I have to do this week. All right. I think that's good. I think it's time to take the doggy to the park. She wants to go to the park. She's been looking at me down there like, go to the park. Why are you no, just with the doggy? I'm gonna go take care of my doggy. He needs me. Thank you for listening. See you next time. Dun dun. Dun 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 dun. Dun 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 dun. Dun dun.